In this video, we're going to talk about how we match up or how we correlate rock layers in different areas. So again, correlation is just trying to figure out where rocks that are the same type and the same age match up between different areas. Sometimes this could be just on the other side of a canyon wall, like in the Grand Canyon. Sometimes it can be just a few miles away. Other times you can be trying to match up rocks between different continents. And we'll see that when we're looking at these different rock layers, we care a lot about the fossils that are inside of them. Because if we can figure out when that animal that was fossilized was alive on the planet, we can figure out when that rock layer was deposited. And if we're able to match up sedimentary rock records from multiple locations, it's just going to give us a much better picture of what the geologic history in that area actually was. In the 1700s, a geologist looked at the canal systems near his house and realized that there was one layer of sediment that was incredibly unique. The fossils inside of it were totally different than the fossils in the sediment above and below the specific layer. And it led him to this idea that fossils can be used to identify rock layers, when they possibly could have formed, and to help match up rock layers between different areas. And this led to the principle of fossil succession. And this is the last one of our relative dating principles. But with this principle, it tells us that over geologic history, different organisms succeeded one another in time. So, for example, we might be looking at an extinct animal called a trilobite that was here right at the beginning of the Cambrian during the Paleozoic. But trilobites are extinct now. So if I found a trilobite within a sedimentary layer, I would know that that layer formed during the time that the trilobites lived. But now on Earth, we don't have trilobites. It would be more likely that I would find a fossil with, let's say, a chicken bone inside of it instead. So by looking at the different layers of fossils within the rock, it helps us understand how life evolved through geologic history. And the best way to do this is through index fossils. There are lots of different types of fossils out there, but index fossils are the best at helping us quickly figure out a time period that a rock or sedimentary layer could have possibly formed. And that's because with index fossils, these are organisms that are geographically widespread. They're found in a really large geographical area, sometimes on multiple continents, but they're also around for a really short period of geologic time. So typically these index fossils might be around for like 10 million years. That might sound like a long period of time, but remember that the Earth is 4.5 billion years old. So 10 million is a very small proportion of that total amount. So index fossils, they're found everywhere. They're geographically widespread, and they're found for a very short period of geologic history. If we find one of these trilobites, like we see in the upper image, this is a really important index fossil. It's going to help us be able to not only identify the age of the rock that it formed in, but also help me be able to correlate rocks between different locations. But you don't always find index fossils. Most of the ones that we find are really common organisms. So if we don't have index fossils, we can look for a fossil assemblage. This is kind of like a collection of fossils all in the same rock. And it can be used whenever there aren't index fossils to kind of figure out what the environment was like and when this rock could have possibly formed. And on top of that, we see that fossils are really good at being basic environmental indicators. So for example, if I were to find a rock with a fossilized coral inside of it, I would know that that rock formed in a location that was a warm, shallow sea, because that's the only place that coral grows.